Okay. So Sima, next topic which we are studying is radiation. So radiation is the third method of transfer of heat energy. So conduction, convection, they require medium. Radiation doesn't require any medium. So transfer of heat without any medium is called as radiation. So why it doesn't require any medium? Because at the source, whichever is producing heat energy, at the source these radiations, this heat energy, it is converted into electromagnetic waves. Okay. And electromagnetic waves, they doesn't require any medium for traveling. Light doesn't require any medium for traveling. So therefore heat energy, because it is converted into electromagnetic waves, so it doesn't require any medium for traveling. And once it is converted into electromagnetic waves, they travel with the speed of light. Light speed 3 into 10 power 8 meters per second. So these heat waves also, they travel with the speed of 3 into 10 power 8 meters per second. And not only that, they follow all the properties of light also. Light, it will show reflection, refraction, all these properties it will show. Wave properties are there here, particle properties are there. So all these properties, they are satisfied by heat waves also, because they are also converted into electromagnetic waves. Understood, Noma? But once they strike the surface of any material, so these electromagnetic waves again, they are converted into heat energy. Are you able to understand? Now see. So let Q be the total heat energy striking any surface. Clear, ma? So out of this total heat energy, okay, ma? So Q can be written as Qt plus Qa plus Qr. I can write like this. Okay. Out of the total heat energy which is reaching a surface, it can be divided into three types of heat energy. So amount of heat energy which is transmitted through that body. Okay. And Qa means what? Amount of heat energy which is absorbed by that body. And Qr means the amount of heat energy which is reflected by that body. Are you able to understand? So for example, if I take this pen, if I keep this pen in sunlight, sunlight will be received by this pen. Electromagnetic waves come and strike this pen. Immediately those electromagnetic waves of heat, they are again converted into heat energy. So this is the total heat energy. And out of this total heat energy, this pen may do three things. It may absorb some energy. Its temperature will rise. No? Temperature of pen increases. No? Why temperature rises? Because it is absorbing some energy. And it is visible to you in sunlight. Why it is visible? Because some of the light, they are reflected also. Okay, some of the heat may be reflected also. And some of the heat energy, it may be transmitted also. But this body cannot transmit energy because this is an opaque body. No? For example, if light falls on a glass, so light will enter and go out of the glass. No? So that is the amount of energy transmitted. So this total energy can be divided into three types of energies. The amount of energy transmitted, amount of energy absorbed, and amount of energy which is reflected. Okay, so right now. So Qt means what? Qt means energy transmitted. Okay. Qa means what? Energy absorbed. Okay. Everybody may not absorb energy, ma. Okay. And Qr means energy reflected. Are you able to understand? This is how I can write a relation between them. Okay. Now what I do is, completed this side. What I do is divide this individual energies by total energy. So what I do, Qt plus Qa plus Qr divided by Q, this is equal to sigma. So therefore, if I divide both of them, this is what I will get now, Qt by Q, Qa by Q, Qr by Q. They can be written as T plus A plus R is equal to 1. So if I rearrange them, R plus A plus T is equal to 1. Okay. Now what is meant by R here? R is called as reflectance. Reflectance. And how can I write the definition of reflectance, ma? Ratio of heat energy ratio of heat energy reflected to total incident energy, total incident heat energy. Understood, Tom? This is called as small r, no? R is called reflectance. Reflectance means this one only, no? This ratio. What is this ratio? QR means what? Amount of energy which is reflected. And Q means total amount of heat energy which is incident. So the ratio of these two energies is called as reflectance. And can you say what can be the unit of this one? Unit of reflectance. No unit, because energy unit is joules. This is also energy only, no? Joules by joules, no units. So this is just a ratio. So ratios does not have any units. Clear, no? So similarly, then remaining ratios I hope you can write, no? So reflectance, absorptance, transmittance are dimensionless. They doesn't have any dimension. Okay. Now what is meant by A? A means absorptance. Absorptance. Clear, no? And what is meant by absorptance? Again same. Ratio of energy absorbed to the ratio of energy incident. Understood, Nama? Similarly, we write T. T is called what? T is called transmittance. Okay, ma? Transmittance. So transmittance can be written as QT divided by Q. Understood, no? So these are the ratios and these are the names which you should remember. Okay. So this reflectance is also called as reflecting power. Reflectance also you can call it as reflecting power. Similarly, absorptance you can call it as absorbing power. Okay, ma? And transmittance you can call it as transmitting power. Understood now what is happening? Clear, Nama? And these are the values for total energy reflected and total energy absorbed. Are you able to understand? Now we write one case. Okay. So if we study these values at a particular wavelength, okay, ma? Then these parameters are called monochromatic or spectral Understood now? This is one important point which you should remember. Now what is Q? Q is the total energy, no? At which wavelength? At every wavelength. All the wavelengths we are studying. For example, the energy which you receive from sun, in that energy every wavelength will be present, no? All the wavelengths will be there. Similarly, in the amount of energy which is reflected, all the wavelengths will be present. Instead of studying energy at all the wavelengths, if you study the amount of energy reflected and the amount of energy incident only at a particular wavelength, then they are called as monochromatic, or you can call it as spectrum. Okay, and they are represented by A lambda. A lambda means what? Monochromatic absorptance. Monochromatic absorptance, or you can call spectral absorbing power. Spectral absorbing power. Okay, ma? So are you able to understand the difference, ma? What is happening? In this heat energy, many wavelengths will be there. In sun, even in white light also many wavelengths are there, no? Now instead of studying all the wavelengths, if I study the amount of energy emitted, amount of energy reflected, amount of energy transmitted at a particular wavelength, then we can call them as monochromatic absorptance or spectral absorbing power. Similarly, you write for R lambda and next what? T lambda. Okay, write these values also. What is R lambda? Monochromatic reflectance or spectral reflecting power. Understood, no? T lambda, monochromatic transmittance or spectral transmitting power. That's it. Okay, next. So the next concept is total transmittance or total transmitting power. Sorry, total emittance and total emitting power. So emittance means what, Sima? For example, heat energy, for example, this is a heated body. Okay. So this heated body continuously it will be giving energy to the surroundings, no? Here, no? Continuously energy will be given to the surroundings. So how much energy it is emitting per unit area of that surface per unit time, that is called as emissive power or emittance. Are able to understand ma? Amount of energy it is emitting. For example, if you take heated body, continuously it will be emitting radiations, no? So how much energy it is emitting per unit area per unit time at every wavelength. Okay, ma? So here what is the important point? So we consider all wavelengths. Okay, ma? So what is the energy transmitted? Sorry, what is the energy emitted at every wavelength? That is called as total emittance or total emitting power. Now instead of that, if I study this emitting power at a particular wavelength, then it is called as monochromatic emittance. Monochromatic emittance, or what can you call, or spectral emissive power. Spectral emissive power. Are you able to understand? So therefore, this I can represent by E lambda. It means emitting power at a particular wavelength. So this can be written as Q divided by A multiplied by T multiplied by wavelength also. Okay. It means what is that wavelength where you are studying that emissive power, you divide by that lambda also. Then you will get the spectral emissive power, or you can call it as monochromatic emittance. This is the equation. Understood, no? Now what can be the units of this one? Energy is measured in joules, no? Area is measured in unit square, time is measured in seconds, wavelength is measured in meters. Wavelength is measured in angstroms, but I have taken SI system only, no? So I will write meters only. Are you able to understand? But this person has taken angstroms, ma.
Seconds.
Okay. I think calculation should be done in angstroms only, but dimension wise it is meters only. So make a note of 2 here.